So the last few comments from myself is about the potential role of next generation and emerging nuclear energy systems, not so much here at UCSD, but around the world. And perhaps the first place to start is, in the wake of Fukushima, why even bother with the question? I guess my answer to that comes back to the slide which I showed at the very beginning. This is the business as usual carbon trajectory, and then the trajectories we need to follow, one of these sort of multicolored trajectories where we peak our carbon emissions fairly soon. And that gap must be filled by some sort of carbon-free energy systems. I talked a little bit earlier about the scale and scope of the power demand around the world, and it's really important to keep the global perspective in mind here. Terawatts don't mean anything to any of us, so it's a whole lot of toasters or a whole lot of large-scale power plants, and that our options are limited by physics, and they're pretty much the ones at scale are shown on this page. And you've just heard some really interesting talk about how can we adopt renewable energy into our electricity systems from our other speakers. And so the work that's going on here at UCSD encompasses sort of the topics within this little box. And I'm here to talk a little bit about what the prospective role for nuclear-based sources are. Nuclear energy is actually expected to be a significant carbon-free energy source into the future. This is showing both real data and projections into the future of where we expect the world to get its electricity over the next 20, 25 years or so. And you can see that coal and natural gas still play a significant role. And in fact, if you stare carefully, this reminds you of David's comments at the very beginning. Coal, unfortunately, is beginning to take a larger fraction of the energy demand, electricity production. Gas, particularly in this country, is growing rapidly because of hydraulic fracturing. It's not clear whether that will propagate around the world or not. I think the time will tell. Hydro is growing, in the rich world, it's essentially saturated, so it's not changing it anymore. But large-scale hydro is being adopted in some regions of the developing world. And then renewables and nuclear are both expected to grow quite significantly over the next several decades. But I would say that, as David pointed out in his learning curve, or perhaps the unlearning curve in the case of nuclear energy, economics will be the make or break for this technology, as it will be, frankly, for all energy technologies. The business as usual in the nuclear business is not going to work. LWR is an acronym for light water reactor. This is the technology that's deployed around the world. The capital costs are too high. The perception of unacceptable safety risks is there, and it's real. The perception is real. We can talk about that maybe during the Q&A. The question of what to do with spent fuel is still out on the table, and there are concerns with proliferation of weapons-grade materials. So what is needed? Well, obviously the capital costs have to come down into the range that's competitive with other energy technologies. David showed that the costs have risen to maybe factors of 2 to 3 higher than the values that I show here. Also, conventional nuclear technologies that are already deployed are very large unit sizes, and the market wants generally smaller unit sizes for power sources. We need, in my opinion, enhanced reactor safety. I sometimes get into discussions with colleagues in the nuclear business about this point. In my view, we need what I term walk-away safe, and that is so that the failure of the core, like we've seen in a few spectacular instances, is physically impossible. It's not just unlikely, but is impossible from a physics standpoint. And there are schemes that we think that could do that, but we haven't deployed them. We need a workable solution for spent fuel, and in my view, that involves vastly reducing the quantity that's produced and reducing the lifetime of the radioactive materials down to something that we know how to handle in an engineering system, something that's not tens of thousands of years, but it's measured in decades, and something that's proliferation resistant. There are emerging concepts that may help resolve these issues. There are a number of competing designs now that are trying to move into production and being tested in the market, called small modular generation 4 designs. I showed a schematic from one such vendor. There are 3 or 4 that are out in the commercial world. And there's work in controlled fusion, which is what I end up working, that's what I spend my time working on. And I've shown a cutaway drawing of a device. It's called ITER, which is a reactor under construction in France, which will produce 500 megawatts of heat, not electricity, but heat from fusion energy, expected to do that in the decade of the 2020s, next decade. So that's the end of my comments on nuclear, so thank you for your attention. And as we sort of transition to the Q&A, I tried to think of a few questions that came to my own mind, and hopefully you guys have many others, but the questions that I could think of is, to what degree, taking with the knowledge and expertise that our panelists have, to what degree can we integrate renewable sources into our power distribution systems, into our smart grids? What roles does the architecture of such systems and resource forecasting and demand response play in answer to that question? That is, if we really learn how to integrate demand response and forecasting, how far can we push that renewable source as a primary source of electrical energy? What are the key issues that that we need to solve to really make utility scale energy storage and ground transport possible, to really move to a dominant EV technology for our ground transportation? What role do we as a society wish to have, if any, to have nuclear energy play in both the developed world, the rich world, and the developing world? And how can we resolve these so that we can begin to make the really large reductions in carbon intensity in our electricity system, so that we can actually meet the legitimate energy demands of human beings and satisfy our need to transition away from fossil fuels? So let's, Carlos, if you could come back up, and I guess I have to sort of play a dual role here, I guess, as the moderator, unless Jerry or somebody wants to do that. So questions?